This is section 4.1, and we're going to go back to graphing parabolas, but we're not just graphing them in vertex form that we're used to, we're graphing them in standard form. But even before going to graphing quadratics, what is a quadratic? What is a quadratic function? What is a quadratic equation? Anybody know what a quadratic is? How about a linear function? What's a linear function? Anybody? This from Algebra 1. What's a linear function? So a linear function is an equation that when you graph it, it graphs a line. And we know different forms of linear functions back in Algebra 1. Y equals mx plus b, that's a linear function. Point slope form, y minus y1 equals m parentheses x minus x1, that's a linear function. They're called linear functions because when you graph them, they graph lines. What is a quadratic function? A quadratic is anything that has the x squared in it. So when you have y equals x squared, that's a quadratic function. And we should be familiar with this parent graph of all quadratic functions, of all parabolas, right? The y equals x squared. It has the coordinates 1, 1, 2, 4, 3, 9. We've already dealt with that. That's the actual pattern that we use to graph from the vertex, or we modify the pattern. But that is a quadratic because whenever you have an x squared, it's a quadratic. And it doesn't matter if you have a single x squared or if you have maybe like x squared plus 2x plus 3, that's also a quadratic function. As a matter of fact, this quadratic trinomial is in standard form. What is standard form? Where you have y equals ax squared plus bx plus c. And of course the a is 1 in this case, the b is 2 in this case, and the c is 3 in this case. So this is a form that we need to know, standard form. So standard form is y equals ax squared plus bx plus c, where your a, b, and c are just numbers. Okay, and we should know what vertex form is. What's vertex form? Vertex form? It's y equals what? A parenthesis x minus h close parenthesis squared plus k, right? Guys, we should all be pros at vertex form right now. So just like in Algebra 1, or just like when we graphed lines, we had two different forms. We had a slope-intercept form, y equals mx plus b, and point slope form. Right here, graphing parabolas, graphing quadratics, we have two different forms. We have standard form, and we also have vertex form. So we need to know both, okay? What else do we need to know right here? It says, review x and y intercepts from Algebra 1. Do you guys remember x and y intercepts from Algebra 1? Anybody? Yeah, what is an x-intercept? What does that mean? Like, what's the definition of an x-intercept? The point where your line crosses the x-axis or your graph crosses the x-axis. So I have a little example here. Here's an xy plane with a bunch of lines on it. Now, if we look at that blue line, it crosses the x-axis at the location -6, 0. If we look at this black line, it crosses the x-axis at -4, 0. This line right here crosses the x-axis at 0, 0. The yellow line crosses at 2, 0. The red line crosses at 4, 0. The green line crosses at 6, 0. What could he tell me about all of those x-intercepts? Anything stand out? Anything special? All the y values are what? 0, right? That's 0. This one over here is 0. This is 0. All the y values are 0, and that's not coincidence. I mean, any point on the x-axis, which will be an x-intercept, has to have the y value of 0 for it to be on the x-axis. So back in Algebra 1, we should have known how to find the x-intercept and the y-intercept. So we just saw a bunch of x-intercept values, and we said that all of those x-intercept values have the y value of 0. So algebraically, to find the x-intercept, we must set y equal to 0 and solve. Okay, you guys might want to take notes on this, especially if you don't remember from Algebra 1. If you do, you're good. Right? How do you find the x-intercept? You set y equal to 0. And it's not that some mathematician just magically created that rule. The fact is, if you're looking at x-intercepts, the y value is going to be 0. It doesn't matter which x-intercept you look at, the y value is always 0. Now, if you look at the y-intercepts, right? If you look at the y-intercepts, we have the y-intercept at the location 0, 4. We have this y-intercept at the location 0, 2. This one 0, 0. This one 0, negative 4. The y-intercepts have to have what? The x value has to be 0, right? So to find the y-intercept, you're going to set x equal to 0 and solve, right? So these are things that we should remember from Algebra 1. To find the x-intercept, you set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve. Okay. Now this is I will ask you today to find the y-intercept of a parabola that's in standard form. Okay. Again, standard form is y equals a x squared plus bx plus c. And finding the y-intercept for any quadratic function that's in standard form is the easiest thing that you'll ever do in Algebra 2. Why is that? Because if you set x equal to 0, remember a, b, and c are just numbers. And if you set the x to be 0, then 0 squared is 0. 0 times any number is 0, and 0 times any number is 0. So all of this ends up being nothing, and the c value is your answer. So the y-intercept on a standard form quadratic trinomial parabola will be the c value. Okay. Anyway, we'll get to that in a little while. Today, what we want to do is be able to look at a quadratic trinomial equation in standard form and be able to give all kinds of information without even looking at the parabola. Okay. So I would like you guys to copy down those instructions up there, and I would also like you to copy down this first question right here. And at the end of it all, I don't really care about the number, right? I mean, yeah, you should always start with finding the vertex. Doesn't matter if it's in vertex form, if it's in standard form, if you're just wanting to state information, or even if you're graphing, you always start with the vertex. So that makes sense that the vertex is the first thing to state. But, I mean, you might want to state the axis of symmetry next. You might want to state the y-intercept because it's so easy, the domain and range. So I just want you to state these 5 different things. And in this case, I do number them 1, 2, 3, 4, 5. But I don't really care about the order. But I do care that you're able to come up with all these 5 bits of information of a parabola that you can't even see, just getting the information algebraically from this standard form quadratic trinomial equation. So like I mentioned previously, yes, starting with the vertex is the best. Whether you're graphing or whether you want to state all kinds of information, you want to start with the vertex. And it's really easy if it's in vertex form. If it were y equals a parenthesis x minus h close parenthesis squared plus k, you could just see the h and the k, and that's your vertex. But the problem here is you don't have an h and k. It's ax squared plus bx plus c. So you cannot see the vertex. So what you were supposed to learn yesterday was the formula to find the x value of the vertex. So let's begin by writing down number 1, vertex. We know it's going to be a coordinate. We know it's an x value and a y value. But how do we find that vertex? We're going to use the vertex formula x equals negative b over 2 times a. Now that formula is only for the x value of this vertex. And when you use this formula, I recommend using parentheses where your b is at and where your a is at. That way you could safely identify that your a value is 3, your b value is negative 6, and your c value you don't care about because c is not in the formula. But let's plug in the negative 6 as the b value and plug in the 3 as the a value. And this formula will give you the x value of your vertex. A minus 6 will change to a positive 6. So you will have positive 6 up on top over 2 times 3, which is a positive 6 on the bottom. So what do we know? We know that x equals 1. So the x value is equal to 1, and we're talking about the x value of our vertex is equal to 1. Okay? Now on any equation, whenever you have your x and you want to find your y, all you have to do is plug it in, right? So I'm going to rewrite this quadratic trinomial equation exactly the way it is, but instead of the x's, I'm going to put parentheses because I know what my x's are. What are my x's? My x's are the value of 1, right? We found out that x equals 1. So I'm going to plug in a 1 on both of these with parentheses. And whenever you plug in that x, I highly recommend use parentheses, and we're plugging in the 1 right there and the 1 right here. A lot of students make mistakes when they're doing this part of the math, right? You have to use PEMDAS. You always start with parentheses, but of course there's nothing in the parentheses except the nice natural number 1. So then you move on to e exponents, and we do have an exponent. So you must do 1 squared first. Do not multiply 3 times 1 and then say, oh, 3 squared is 9. That would be wrong. You got to say 1 squared. What's 1 times 1? It's 1, right? So what we really have here is 3 times 1. And what is 3 times 1? That is simply 3. And then in the middle term, we have a 6 times 1. That is 6. And of course, we have a minus sign. And the last term is a minus 4. There we go. So that's just 3. Take away 6, take away 4. You could do it in your head. You could do it on the calculator. Your answer will be -7. Are you with me? Okay, so what did I just find? I found that the y value equals -7. And we are talking about the y value of the vertex. So the y value is -7. I'm going to put that right here. And that's the hard part. Everything else is cake from here. Everything else is easy from here. Once you find that most important point, right? Even when you're graphing, once you find that vertex, if your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. If your a value is 3, you could modify the pattern. So once you find that vertex, everything else comes easy, right? Like I could just look at the vertex and I will know my axis of symmetry. My axis of symmetry is what? The equation what? Anybody? X equals the x value of the vertex. Yeah, x equals 1. Thank you. I already know my domain, and I could even already know my range if I understand the a value and I understand the vertex, which is the highest or lowest point, the most important point of a parabola. Anyway, I'm just talking. Let me actually start writing all my answers here. So let's move on to the second thing they asked for, maximum or minimum value, okay? So maximum or minimum, does this parabola have a maximum or a minimum value? If I throw something up in the air, right? Like, okay, so here's a little red dot. I throw it up in the air. It's going up, 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 and then all of a sudden it reaches a maximum value, then it comes down. Does that make sense? So when something goes up in the air, reaches a maximum value, then it comes down, that is a parabola that's opening down. So if your parabola opens down, it will reach a maximum height, max height, right? So let me ask you this. Does this parabola open down? Based on what you know? No, it opens up. So we know it opens up. So, I mean, we kind of, knowing the a value, we kind of know that it opens up, and we even know something more, that it's kind of narrow. It's kind of narrow because the a value is 3. That got vertically stretched by 3. So if it does open up, and you're looking at the parabola from left to right, or from right to left, but from left to right, it's going down, 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 and then reaches a minimum value, and then it comes back up. Does that make sense? So if it opens up, you're going to have a minimum value. Right here, this would be a minimum. But if it opens down, then you have a maximum value. These are things that you need to know, but it's common sense, right? If you throw something up in the air, what does that parabola look like? It looks like it's opening down. And if you throw something up in the air, it's going to reach a maximum height and then come back down. For something to have a minimum value, it has to open up. It's going down, 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 reaches the lowest point, which is technically the y value of your vertex, and then it goes back up. Okay? Anyway, so to answer this second part, do we have a maximum or minimum value? What do you guys say? Do we have a max or min? Minimum, because it's opening up, so it has to be a minimum. So we're going to write down number 2, minimum. And not only that, we're going to say what the minimum value is. The minimum is at what? What is the minimum value? Where could I get that from? I'm talking about the most important point of a parabola. Say again? The y value of the vertex, right? The vertex is the most important point. It's the highest point or the lowest point. In this case, knowing that it opens up because it's positive, it's the lowest point. So you could say that the minimum value is at, and you could give the coordinate of the vertex again. You could say is at 1 comma -7. Or you could say the minimum value is at, you could just say -7. Or you could say the minimum value is at the y value of -7. All those 3 answers are technically correct. Does that make sense? Okay, so you could say once again, what's your minimum value? It's at -7. That's it. You could just say that. But you could also say the minimum value is at the y value of negative 7. Or you could even say the minimum value is at the location 1 on the x, negative 7 on the y. That's precise location on the xy plane. The next one that they want you to answer is axis of symmetry. Okay, so we have, let me box in what we have so far. We have the vertex, we have the minimum value. 3, they want the axis of symmetry. And now that's really easy because you already know the vertex. And if you know the vertex x value, you know your axis of symmetry equation. What's the axis of symmetry equation? X equals the x value of the vertex. Remember that? 1. So there's your axis of symmetry equation. And that one you do have to write it x equals 1 because that's the only way to get a vertical line. The fourth thing that they asked for, the y-intercept. And at the beginning of this lesson, we talked about what do we do in algebra to find the y-intercept? We set x equal to 0 and solve. So to find the y-intercept, we have to set x equal to 0 and solve, right? Now that is ridiculously easy because when you put a 0 here and here, then 0 squared is 0, 0 times 3 is 0, 6 times 0 is 0, 0 take away 0. This whole thing becomes 0 except for the c value. So finding the y-intercept of a standard form quadratic trinomial is the easiest thing in the world. The y-intercept is simply your c value, which in this case is negative 4. And that is the fourth thing that they ask for. Does that make sense? Now, that would not be true if I had a vertex form, right? If I had a vertex form, y equals, let's say, 2x minus 3 squared plus 5, your y-intercept is not 5. It's not 5, okay? That doesn't work right there. Because vertex form, this is your vertex, negative 3, 5. The y-intercept being the c value only works when you have standard form. Because again, the explanation, how do you find the y-intercept? You have to set x equal to 0, put a 0 there and a 0 there and solve. That'll always leave you the c value on your standard form, not on a vertex form. Last thing that they ask for is the domain and range. So in this case, the fifth thing, the last thing, the domain. What's the domain of any parabola? Yep. And how about the range? The range is y. It's either going to be at or above a certain value, or at or below a certain value. And you have to understand the a value and how it looks in order to determine if it's greater than or equal to a certain value or less than or equal to a certain value. So what is the range? Is this opening up or down? Up. So the lowest value we know is the y value of negative 7, and it's above, right? The whole parabola is above. It's at negative 7 or above. So the range is y is greater than or equal to negative 7. And we have stated so many details of a parabola that we have not even seen. Does that make sense? Yeah. Okay. If I did ask you to graph this guy, well, you would have to do step 1, find the vertex. You always find the vertex no matter what. It's the first step on anything, on any quadratic. When you're graphing or when you want to state all this information, find the vertex. Once you find that vertex, you could use the pattern, the modified pattern. Instead of 1, 1, 2, 4, 3, 9, it would be 1, 3, 2, 12, and 3, 27, which you're not even going to use. But you would use that modified pattern because the a value is 3 to graph it. So just to make everything related on a graph, this parabola, I'll do a quick sketch. The vertex is 1 on the x, negative 7 on the y. It's going to be way down here somewhere, right? Just going to put a dot right there. That's a vertex, negative 1, negative 7. I know that it's opening up because the a value is positive. I know that it's vertically stretched by 3, so it's going to be pretty skinny, pretty narrow, right? Not only that, because it's in standard form, I know that my y-intercept's negative 4. So if I actually go down to negative 1, negative 2, negative 3, negative 4 on the y-axis, I know it's going to cross right here. So I could actually put a dot right there at the y value of negative 4, map it over to the other side, and we got our pretty skinny graph right there. Just to relate everything. So great question. You just asked if the range is always going to be greater than or equal to or less than or equal to. Is it always going to be or equal to, or is there going to be a situation where you just have a greater than or less than? When we're dealing with inequalities, right, where you have solid parabolas and dotted parabolas and shading, then, and we haven't gotten there yet, or have we? Well, anyway, when you're dealing with inequalities, like let's say this parabola was dotted instead of solid, and you had it shaded above, which would be inside the parabola, then you would have a greater than symbol. But when we're talking about just regular parabolas that are not inequalities, then yes, it's always going to have an or equal to, because all of these parabolas are solid parabolas and no shading, right? But if you're dealing with quadratic inequalities that have shading, then if your parabola is not solid, then yeah, your range would not be or equal to. It would just be greater than if it's shaded above. Anyway, let's continue. Let's go to this one right here. So on Google Classroom, you'll find all 4 of these questions. I would like you to practice all 4 of them. And there's a video explaining all 4 of them. These are the majority of the questions you're going to have on the quiz this Friday. Okay? So whether you're graphing or trying to state all kinds of information, what's the first thing that you should do? Find the vertex. The vertex is a coordinate, which is really an x value and a y value. Now, we know that if it were in vertex form, the vertex would be hk, but it's not in vertex form. It's in standard form, where you got the ax squared, the bx, and the c. Okay? So I'm going to have to use the vertex formula. The vertex formula is x equals negative b over 2 times a. And I always recommend for you to use parentheses instead of the b and the a when you plug in the b and the a. So I'm going to plug in my b value of 6 right in there, my a value of negative 1 right in there. So what do I have? I have x being equal to negative 6 up on top over negative 2 on the bottom. That gives me a positive 3. Make sense? All right, so the x value of our vertex is positive 3. For the y value, anytime you have an x and you want to find a y, please plug in the x into your original equation. So my original equation is y equals negative x squared plus 6x plus 2. Notice that I put parentheses instead of x, because I know that my x value is 3, and I'm going to take that value of 3 and put it right there and right there. So 3 right there, 3 right there. Again, this does not say negative 3 squared. This does not say negative 3 squared. Even though it looks like it says negative 3 squared, it doesn't. This is actually saying negative 1 times 3 squared. All right, so of course you have to do exponents first. 3 squared is first, and 3 squared is 9. So you'd have a 9 right there, but that negative that's out in the front, it just comes down and you have to put it in front of your answer 9. Okay, so we have negative 9, and then we also have 6 times 3, that's 18. Of course, there's a plus sign right here, and last but not least, the plus 2 that just comes down. So when we do this math, negative 9 plus 18, that's positive 9. Positive 9 plus 2, that is 11. Okay, so what did we just find? We found that the y value equals 11. Okay, so the y value of our vertex will be 11. So now that we know that most important point, everything else will be pretty easy. The axis of symmetry comes from the vertex, x equals 3. The range comes from the vertex. It's either going to be y is greater than or equal to 11 or less than or equal to 11, depending on if it opens up or down. The max or min value comes from the vertex, right? So everything comes from the vertex, except for the y-intercept. That's simply the c value of your standard form equation. So let's move on to the second thing they asked for. Do we have a max or a min value? We have the vertex. Do we have a max or a min value? We have a max value because this is a negative a value. Negative means that the parabola opens down, okay? And if it opens down, that means it's going up, 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 reaches a max height, then it goes back down. So we know for sure that that's max value. And what is the maximum value? And when we are talking about maximum height or minimum height, We're talking about y values, right? So what is the maximum height that this reaches? 11. So the max is at 11. Or you could also say max is at the y value of 11. Or you could say the max is at the location 3, 11. All those are perfectly fine answers for stating the maximum value. Are you with me? Alrighty, let's move on to the next one. Axis of symmetry. That one's ridiculously easy. How do we do the axis of symmetry? X equals 3. Perfect. And that is simply x equals the x value of your vertex. So you have to write x equals. You can't just say 3. 3 is just a number. This x equals will provide that vertical line that crosses right through the vertex if you were graphing. So there's your axis of symmetry. So I'll look at all these things I could ask about these standard form quadratic trinomial equations without even graphing them, right? Moving on to the y-intercept. That's the easiest thing in the world. The y-intercept, of course, you have to set x equal to 0 and solve, but on a standard form quadratic, it's simply your c value. So what's the y-intercept? 2. So y-intercept is 2. That's an acceptable answer. Another acceptable answer is the actual location of the y-intercept, which would be 0, 2. That makes total sense because how do you find the y-intercept? You set x equal to 0, and if you did set x equal to 0, you'd get 2 as an answer. So you could say y-intercept is at 2, or you could actually give the location of the y-intercept. Wait, did I say x-intercept? I meant y-intercept. The y-intercept is at 2, or you could give the location of the y-intercept 0, 2. Yay? Okay. What else? So that was the fourth thing. And the last thing, domain and range. The domain, x equals what? All real numbers. Range, y is what? Less than or equal to that y value of the vertex, 11. Perfect. So this is the majority of the questions that you're going to see on Friday's quiz, all right? Getting a standard form quadratic trinomial equation and being able to state the vertex, being able to state the y-intercept, the domain, the range, and all that other stuff. I would like you to try the other 2 questions, and they are on video, so for you to check your answers, you got to go to Google Classroom and check those videos. That way you could try 3 and number 2. But before I let you guys get to work, there's also this worksheet on Google Classroom, and this is just practice right here. And I did all of them, but you don't have to do all of them. Homework is just practice, right? Let me actually tell you, these 2 graphs ended up being really messed up. Number 3 had like a vertex of 1/2 and 1/2. I did it. You don't have to do it. I'm not going to give you a vertex at 1/2 and 1/2. And these guys down here, this is the real good practice because I want you to state everything that you can about these quadratic trinomial equations just looking at their graphs. Let me actually show you my answer page. So here's the answer page. And no, that's not the answer page. What am I doing? Sorry about that. There's the answer page. So the first one works out pretty good. I recommend graphing that first one. The A value is 1. That's pretty nice. You could use a pattern 1, 1, 2, 4, 3, 9. I would do number 1. That's good practice. And then down here, I kind of modified the instructions. I want you to answer all kinds of information. I want you to state the maximum or minimum value. I want you to state the domain and range. I want you to state the y-intercept and the axis of symmetry. And of course, in order for you to state all those things, you need to know the vertex. So always start with the vertex. You don't have to do all 6 of them the way I did, but just do a couple of them until you're comfortable. Now, if you want to guarantee yourself the best knowledge, then go ahead and practice with all of them. But I recommend doing these and checking them with the solutions that I provided here. Even this word problem is pretty cool. It's about a situation where somebody throws something up in the air and they give you the formula for the way the ball travels through the air, right? And they ask for the maximum height, right? And when they talk maximum height, what they're really talking about is the vertex. So you could apply what you know here to be able to find the maximum height of the ball. Anyway, this is all practice. I did every single question on this worksheet. You don't have to, especially these guys. These guys came out really nasty. I wouldn't do these. I would definitely do the first one. And that's about it. All this stuff will come out on the quiz Friday.